I'm going to talk to you guys about the properties of waves. So waves have three properties, which is wavelength, amplitude, and also frequency. The wavelength is also known as lambda, is the distance between two identical points on successive waves, which is the points on the peak to another peak. And the amplitude is the distance from the mid lane to the peak or the throw. And the frequency is the number of waves that pass through a particular point in 1 second. And the speed of the wave is lambda times frequency.
Hello, Assalamualaikum. My name is Faimah Azam bin Farizan and I'm going to talk about electromagnetic radiation. Okay, about electromagnetic radiation. Visible lights consist of electromagnetic wave. So every light have electromagnetic wave, and electromagnetic radiation is the emission of transmission of energy in the form of electromagnetic wave. So the wave of electromagnetic is like it's like a wave. Yes. So the speed of light in vacuum is 3 times 10 power of 8 meter per second. Okay, now I'm going to talk about electromagnetic wave, graph of electromagnetic wave. So there are many types of wave, such as X-ray, sun lamp, heat lamp, microwave or oven, TV, radio or AM radio. There are many types of color of electromagnetic wave, such as blue, green, yellow, orange and red. So each color have many types of electromagnetic wave. From blue to red, blue is the has lessest electromagnetic wave, and red has more electromagnetic wave.
Okay, now I will show you how to solve a question that is about a photon has a frequency of 6 times 10 power of 4 Hertz. Convert this frequency into wavelength, which is in nanometer. Okay, does this frequency fall in the visible region? Okay, to solve this question, we need to use all electromagnetic radiation formula, which is lambda times wave frequency equals to the speed of light. Okay. Now we need to search for lambda. Okay, so we need to transfer the frequency besides the speed of light. So it will be like this. Right. Okay, we all know the speed of light has a fixed value, which is 3 times 10 the power of 8 in meter per second. So the speed of light has to divide with the frequency, which is 6 times 10 the power of 4 Hertz. Okay, after that we will get a answer in meter, which is 5 times 10 power of 3 meter. But the question here needs need in nanometer, so we have to convert this 5 times 10 power of 3 meter into nanometer. Okay, now we need to convert it in nanometer. uh, 5 times 10 power of 3 over 1 times 10 power of 9 nanometer over 1 meter. So we will get 5 times 12 sorry. So we will get 5 times 10 power of 12 in nanometer. So here is our answer for this question.
Okay, so today we'll show you to how calculate the frequency of the radiation. So the question are, the wavelength of the green light from a traffic signal is centered at 522 nanometer. So the formula for the frequency is V equal to C over lambda. So basically the original formula is V equal to U over lambda, but because this is a light wave, so we change it to C. So we must change from the nano to the meter because it's a SI unit for the frequency. Five point two power of negative 7. And so now by the formula we just substitute the value. So we just substitute the value. So by using calculator, we get the answer is 175. Okay, so basically this is the calculation to find the frequency of the radiation. So if the radiation is not from the light wave, we just use U. Okay, so this is the calculation. I hope you all understand it. Okay, thank you.
I will talk about Planck quantum theory. When solids are heated, they will emit electromagnetic radiation in over a wide range of wavelength. Radiant energy emitted at a certain of temperature depend on its wavelengths. Atom and molecule can emit energy in terms of quantum. Quantum is the smallest quantity of energy that can be emitted in the form of electromagnetic radiation. Okay, the formula of Planck quantum theory is E equal to H times V. E is energy of the single quantum energy. H is a Planck constant, which is 6.63 times 10 to the power of negative 24. V is frequency of radiation. The formula of V is the speed of light over lambda. This is example question for Planck quantum theory. For those who want to read the question, can pause this video. Okay, this video want us to calculate the energy. So we will use the formula of Planck quantum theory, which is E equal to H times V. Okay, as we know, H is a Planck quantum theory, which is 6.63 times with 10 to the power of negative 34 joule second. So V is a frequency. We can change it to another formula, which is H C over lambda. So C is speed of light and lambda is wavelength. So we can substitute from the question. H is 6.63 times 10 to the power of negative 34 joule second with time with speed of light, which is 3 times with 10 to the power of 8 meter per second over with lambda. Lambda is wavelength, 5 times 10 power 4 Newton meter. So we want to cancel out Newton meter with meter and cancel S with S. So we change it to meter. 1 10 negative 9 over 1. So we calculate from this equation, we get 3.98 times with 10 to the power of negative 21 joules. So we can get why we get only joule, because we cancel out Newton meter second with second, so the only left is joule. So for the question B, same step, different of wavelength. So we start with the formula E equal to H times with speed of light over lambda. So we substitute the value 6.63 times with 10 to the power of negative 34 joule second time with 3 time of 8 meter per second over 5 times 10 to the power negative 22 Newton meter. We change it to meter. 1 times 10 negative 9 over 1 Newton meter. So we can cancel out the unit. So for the answer for this question is 3.98 times with 10 to the power negative 15 joule.
Today I want to explain about photoelectric effect. Okay, the photoelectric effect happen when the electron ejected from the surface of the metal because of the light, and it's called minimum frequency, or other name is threshold frequency. Okay, the number electron ejected are proportional to the intensity of the light. Okay, photon is called photon is known as a particle of light. The formula how to calculate photon is Hv equal to Ke plus W. Okay, the H is the Planck constant, V is frequency, and Ke is kinetic energy, and W is work. Okay, I want to explain about how to calculate the energy in joules associated with the photon in the wavelength of the X. Okay, we start with the first key. We start with energy equal to H time with V, and V, we calculate V equal to C over lambda. Okay, we calculate C over lambda firstly. Okay, so we can rearrange the equation. E equal to H, we substitute V with this, times C over lambda. Okay, we enter the value, substitute with the value. The value E equal to 6.63 times 10 negative power of negative 24. The unit is joule second, times with 3 times 10 power of 8 over the wavelength. With the wavelength we change to meter. That we get is 0.154 times 10 power of negative 9. Okay, we calculate this and we get 1.29 times 10 power of negative 15 joule.
Okay, so this is a question for photoelectric effects. For question A, we are trying to find the minimum frequency of light required. So this is the work function, which is W, and then so the original formula is Hv equals to Ke plus W. In this question, we're trying to look for V, and the Ke is also not stated, so the Ke is 0. Ke is 0, and Hv, H is the Planck constant. We are trying to look for V, so V equals to W over H. W is 3.42 times 10 power of negative 19 joules over Planck constant is 6.63 times 10 power of negative 34 joule second. And if you do this equation, you will get the answer 5.16 times 10 of power of 14 second negative 1. Okay, and for question B, we are trying to look for the kinetic energy. So the formula is Ke equals to HV minus W. And you already have all the data, so you just put it in the equation. 6.63 times 10 power of negative 34. Okay, so the frequency for this question was given 1 times 10 power of 15. So H times V, which is 1.00 times 10 power 15 minus the work function, which is 3.42 times 10 power of negative 19. So the answer you will get is 3.21 times 10 to the power of negative 19 joules. So this is the calculation for this question. This is for question A. That's the answer. And this one is for question B. And that is the answer. So I hope you guys understand. Thank you for your time.